Okay, back on the bottom of page 1, we're going to start with accuracy and precision. So the first question that I asked here is there a difference between accuracy and precision? I would assume yes, that's why we're learning about it. So first, yes. Accuracy is going to be referring to how close something is to the real thing, or when we're talking about values, like numerical values, it's going to be how close something is to the right answer. So how close something is to the right answer, or the real thing, or the true value. And then precision refers to how close together measurements are to one another. So how close values are to each other. So I think in my old notes I usually put something like accurate, and then under one of the C's I put correct. So if something is accurate, it is correct. And if something is, I'll draw it over here, precise, we say, I don't even remember. Now I'm totally blanking. I'll remember it. We'll come back and do that one. Oh, I know what it was. It's repeatable. R-E-P-E-A-T-A-B-L-E. Repeatable. Sorry, totally blanked on that one for a second. So if something is accurate, it is how correct something is. If something is precise, it's how repeatable those results are. So you're getting values that are consistent with one another. I almost wanted to call it consistent, but I knew I wasn't using the C again. So if I'm looking at this target, and we're assuming that the goal is to hit the center here, would I describe this kind of thing as accurate, precise, both, or neither? Precise, because this is repeatable. You're hitting pretty much the same spot over and over again, but it's not where you're trying to hit. So precise. This one, if you're trying to hit the center, and you hit here and here and here and here and here, it's pretty decent, but they're not like all right on top of each other. So this is one of the rare cases where you could say that something is fairly accurate without really being precise. And then this one, are you accurate, precise, both, or neither? I would say both, because the accuracy means you're hitting the center target. That's your goal, the right answer, the real thing that you're trying to hit. And then precision means that they're pretty much right on top of each other. We're hitting the same mark almost every time. And then the last one says, draw what it would look like if it were neither accurate nor precise. So if you have a shot here, and here, and here, and here, and then I always draw a little friend who's playing darts with you. Really upset because you don't want to play with someone who's neither accurate nor precise. So with these definitions, what we look at a lot is sets of measurements. Something that happens in labs is that we will take measurements multiple times to make sure that we're being as accurate and as precise as we can be. If you get values that are far away from one another and you're not being very precise, that's an indicator that the calibration of our equipment isn't very good. So we have ways to measure and quantify how accurate things are. So we're going to define the percent error formula. First of all, if we're dealing in a percent, every percent is based on the formula of taking the part over the whole times 100. So we'll see a similar formula to this all the time, but if we're dealing with a percent, it's always the part that we're interested in over the whole thing. So a really basic percent could be what percentage of students in this class are girls, and then I could take the part of the class that's girls divided by the whole number of how many kids are in the class, and then I multiply it by 100, or you'll really just move your decimal twice, and that is how we get any percent. Percent error is going to be a measure of how inaccurate something is. So, for example, if I ask you to guess how tall you are, and you have a true height, you have an actual value of how tall you really are, and then you guess how tall you are and you're not very close at all, you would have a high percent error. You would have a high amount of inaccuracy. So similarly to that, if you have high accuracy, you would have low percent error. So if you guess perfectly, if you're 6'5", and you guess that you're 6'5" exactly and you're right on the mark, your percent error would be 0. The formula that we use to calculate this is going to be taken by the difference between the actual value and the measured value. And because it just matters what the actual difference is, it's an absolute value thing. I am going to say I see a lot of you guys on your phones and computers. Please put them away, turn them off. This is the first math problem, math equation that we're learning, and it's kind of setting the stage for how we're going to do math in this class. It should be pretty straightforward and easy, but I don't want you to get confused because you're not paying attention. So starting with absolute value lines, so that just means that your value is always going to be positive. It doesn't matter if you end up with a negative number. We're just ignoring it in this case. It's going to be your actual value, or the accepted value, or sometimes we'll call it the true value, minus the measured value, so absolute value lines around that, divided by your actual value. So actual minus measured divided by actual. And then in case you don't remember what the lines mean, I'm going to put on here absolute value. What that really means is that it's always positive. So if you subtract actual minus measured and your measured value was larger, you would end up with a negative value on top. But we're saying just ignore the fact that it's negative. All that matters is just the value of the difference. And then we're going to express it in terms of a percentage. So if you need to remind yourself to multiply by 100, you can put that there. And the unit that we're using for this is percent. It's percent error, so that tells me you're going to measure it in percentage. So oftentimes when these situations are posed to us, it will be in a word problem like this. This one says, Jenny massed a 116.3 gram object. Her first measurement was 175.6 grams, and her second measurement was 175.3 grams. Calculate her percent error for both measurements. And then I gave you space underneath this for her first measurement and for her second measurement. So if we're looking at this example, we need to identify what we're plugging in and where. So if we read this and we say she massed a 116.3 gram object, we need to determine, is that an actual value? Is that the true value of how much the object weighs? Or is that a measured value? Is that something that she took as a measurement in lab? And if you're not sure, you can continue on and read through the sentence and try to identify the other numbers first, and then use process of elimination to figure out where this one goes. The next sentence says her first measurement was 175.6 grams. Hopefully this one makes it a little bit more obvious. What value would this be? Would it be an actual value or a measured value? If it says her first measurement was this, it should be really clear that it's a measured value. So specifically, this is going to be her measured for her first trial. So measure, and I'm going to put number 1. So that would go here. And then the other value that I see is that in her second measurement, so her second measurement was this, so this would also be a measured value, but it's going to be value number 2, so we use that for this one. So with that information, can we figure out where this value would go? What would we call this one? In order to solve the equation, we need an actual value and a measured value for each. I already have my measured value, so what do we think that one is? The actual. Perfect. So if she massed an object that had that mass, we're going to say in the context of this, that makes sense that this is actual. So when we plug these into our equation, I'm just following exactly what it says. So it says actual value goes first. I'm going to put 116 and then use my absolute value, 116.3 for actual, minus measured, and this is the first measurement, so we're going to use the measured value from her first trial. So subtract from that 175.6, still absolute value. This is where that matters, because if I just look at 116.3 minus 175.6, you should be able to glance at that and know that you're going to end up with a negative number since what you're subtracting is larger than what you're starting with. But we don't care that it's negative. We're just going to take the absolute value and make it always positive. And then what goes on the denominator? The actual value. So we use that same number, 116.3. Then the important part is that you are plugging it into your calculator correctly. You will always have a calculator available to you on any quizzes or tests that we do in here. I'm going to pause the video real quick so you can grab a calculator. All right, so with your calculators, first of all, start by clearing it. Make sure there's nothing in your screen. You're going to type in 116.3 minus 175.6. When you're done typing in everything on top, everything in your numerator, you're going to hit enter. And then I ended up with negative 59.3. It doesn't matter that it's negative. That's why I keep saying we're taking the absolute value and that it's always positive. And then we're going to divide that by 116.3. You'll hit enter. And then I multiply by 100 so that I'm turning it into a percentage. And my answer, again, always positive, is going to be 50.988, or I'll round up to 50.99%. So my answer here was 50.99%. We'll learn in the next lesson how many places to round to, but for now, we'll say 2 decimal places is sufficient. If you type the whole thing in all at once, so if you don't hit enter between the numerator and the denominator, sometimes your calculator will mess up order of operations and what you intend. So if you do 116.3 minus 175.6 divided by 116.3, you get a completely different answer. You see how that happens? Because what your calculator is doing is the division before it does the subtraction, and so your answer ends up not even close to the same. So I always push enter in between the two. You can write down your number if you prefer to do it that way in multiple steps as well. All right, and then our second measurement, we're going to follow the exact same process for this one, so I'm going to pause and give you guys a minute to set that up yourself. Calculate her second measurement percent error using her measured value from her second trial. All right, looking around the room, it looks like most people have already made their attempts, so let's go through it. First of all, in this one, we're following the same formula, so we're starting with what value first? 116.3, because the actual value is the same for both of these. So absolute value sign and then 116.3 minus the value for her second measurement, so that would be 175.3. Again, finish your absolute value, and then divide that by what? 116.3. So again, we're going to type this in two different parts. So 116.3 minus 175.3 gives me negative 59, but we're ignoring the negative sign. We're just going to pretend it's positive. Divide that by 116.3. And then I multiply by 100 so that it moves my decimal place over twice. So when I record my answer, if we're rounding to 2 decimal places, we're looking at 50.73. The 0 doesn't change anything about that. So 50.73% would be our answer. And then when it comes to math in this class, as well as a lot of things, I am very, 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 very particular about how I grade it and how I want you to show me your work. So the good news is there is so much room for partial credit in all of this. The bad news is if you don't show me your work, you pretty much get no credit. So when I grade a question that looks like this, you get 1 point for showing me the correct value in the correct place. You get another point for showing me this correct value in the correct place. You get another point for showing me this correct value in the correct place. Usually you'll get 2 points for showing me the correct calculated answer. And then you'll get 1 point for using the correct unit. So for a question like this, that's 1, 2, 3, 4, 5, 6 points. If all you did was plug in these numbers into your calculator and get the correct answer and you wrote 50.99 on your paper, you'll get 2 out of 6 points, and that's not enough to pass. So same thing with this, 1 point for the correct number in the right place, correct number in the right place, correct number in the right place, 2 for your calculated value, and 1 for the correct unit. That's another 6 points.